Okay, let's start the session. Good evening, everyone. This is Saravanan, PhD scholar and Prime Minister Research Fellow of NIT Tiruchirappalli. So, as a PMR scholar, as a part of deliverable, I have to teach 2 hours of NPTEL problem solving session every week. So, for that, I have chosen Municipal Solid Waste Management course in NPTEL, and this is the 6th week we are having session. And for this 2 hour session, I have planned like for 1 hour, we are going to discuss the same lecture material what sir has discussed in the videos, and the next 1 week we are going to solve the old assignments problem that was given in 2022 and 23 July sessions. Okay, so for the first 5 weeks we have discussed about what is solid waste, how the waste get generated, and what are the types of waste based on different basis we have classified the waste, and then how the waste can be stored and with types of containers, and how the waste can be transported and collected and transported. Then we have discussed about the secondary collection mechanism and collection route design and collection mechanism design. Then we have discussed about the transfer station and the material recovery facility, that is the MRF. And then processing, we have discussed about the physical processing, that is size separation, magnetic separation, shredding, and then density compaction and all we have discussed. Now we are going to discuss about transformation, that is biological or thermal transformation. In the last week we have discussed about the incineration, that is waste to uh, uh, waste as a fuel. We have discussed in incineration, pyrolysis and gasification, and types of incineration kilns we have discussed, and all we have discussed. Now we are going to discuss about the biological transformation, and this whole week is about composting process. Composting, as we all know from basic itself, that is a simple biological treatment method or a biological decomposition process of organic solid waste. Biologically degradable matter when it is present in the solid waste, it can be this is applicable to wastewater also. For biological degradation we will use aerobic microorganism. The same thing we are using for the solid waste. For with the aerobic microorganism we are degrading the biodegradable organic matter present in the yeah biodegradable organic matter present in the solid waste. So this again another word is called stabilization. So sorry other than decomposition, we are also stabilizing the waste. Whatever the product we are getting, that is the compost, which is a stabilized product. So there is no more deformation or there is no more decomposition at the final product, that is the compost. So it will act as a inert material, and it will be rich in conditioner material, so it can be used as a soil conditioner or a fertilizer. Okay, so the proper definition is composting is the biological decomposition and the stabilization of organic substrate. Substrate is the matter which contains more organic matter and nutrients under condition that allows development of thermophilic temperatures. So that is the one. We have three different types of temperature range. One is mesophilic, psychrophilic, mesophilic, and thermophilic. Psychrophilic is the one which is having temperature range of 10 to 20 or 10 to 30 degrees Celsius. Mesophilic is 20 to 40, and then thermophilic is more than 40 to 80 degrees Celsius. We will call as thermophilic. So thermophilic temperature only this composting will happen. So the bacteria which can survive in this temperature range are called psychrophilic bacteria, mesophilic bacteria, and thermophilic bacteria. Thermophilics we will call. So this thermophilic bacteria are the one which degrades the organic matter and emit heat and carbon dioxide as a product. Final product will be the compost. Solid product will be the compost. So why the carbon dioxide is released? Because we are adding oxygen to the solid waste. So whenever there is a aerobic decomposition process happen, the gaseous product will be CO2, that is carbon dioxide. Whenever there is a anaerobic decomposition happening, then without oxygen, then the product will be gaseous product will be methane, that is CH4. Also some part will be CO2. 75% it will be CH4, and 20% it will be carbon dioxide, and final product will be compost. So the compost can be cured again with the oxygen, and the matured material, the stabilized material we will call as compost, that is the humic substance or inorganic humic substance along with the inorganic and some microorganism. So there may be there is a possibility of some microorganism present at the compost also. So we need to analyze for microorganism before using the compost. So this is the whole process. When organic matter plus oxygen, we will with at a high temperature, that is the thermophilic temperature, it will create carbon dioxide, water and water vapor and energy. Energy in the sense heat. Final product is compost. Okay. So this is the process flow diagram relating with the temperature, that is temperature profile. Whenever there is a heat produced during microbial breakdown, that is whenever there is a microbial breakdown, heat will be produced. That depends on the moisture content of the waste, how much oxygen we had supplied, that is the aeration, and how much carbon nitrogen present, and what is the temperature of the waste. This and all the factor affecting how much heat is produced. So whenever the waste at 0th day, it will be at 20 degrees Celsius in Indian condition usually. So whenever the degradation starts, the temperature increases nearly to 70 degree. That is what I have mentioned as thermophilic condition. Then again it will start reducing. So when all the organic matter will mature at this, stabilize, decompose at this phase, and then again mesophilic temperature will happen. That is less than 40 to 20. Again mesophilic phase will happen. There the compost will be matured and stabilized. Okay, this is the condition. Mesophilic, thermophilic, again mesophilic temperature will persist. Then heat inactivation. What is heat inactivation? Is like whenever there is a microorganism will always be present in a condition, it should be favorable to its growth and reproduction. So whenever there is a excess amount of heat is liberated, then the enzymes of the microorganism will also get affected. So the growth of the microorganism will also get affected. So some of the pathogenic microorganism will die at this thermophilic conditions. So this is called inactivation of pathogenic enzymes. So it will lead to heat death of the cells. So most of the pathogens are killed during the composting process. So this composting process is also not only producing compost but also killing whatever the pathogenic microorganism present in the solid waste. So that is another one advantages of composting process. Okay. You can again see this three phases. First one is growth phase, that is in the mesophilic condition. Second one is thermophilic phase, that is greater than 40, 10 to 40, and then greater than 40 will be thermophilic phase, that is active decomposition and stabilization. Final one is maturation, that is again mesophilic phase will persist. Okay. So here growth of microorganism, then breakdown of protein, fat, hemicellulose and cellulose. These are the organic part of the solid waste that will be broken down. Then finally in the maturation phase, it will take long time, slow degradation of lignin that we are going to see in the next slide. What is lignin? What are the different types of organic matter present in the solid waste? Okay. So here the organic waste after shredding, it will be uh, undergone active composting with microorganism. New microorganism population will be produced, that will again act on the composting process, and some cell death will also happen, that is the pathogens. So moisture will be added, oxygen will be added, nutrient will be added, finally break down into compost, that is a humus product. CO2 and water will also be liberated. Okay. So this is called heat inactivation. At high temperature, some of the pathogenic microorganism will be died. That cell death will happen. But microorganism have a special mechanism for its growth, for its survival. We can say that is spore forming. That is a simple egg kind of thing. That is a spore. So it will be in a kind of what will the pupa will be in the form of spores. That is the endospores, which can resist high environmental conditions like high pH, high temperature, high pressure, it will withstand. So some of the non-pathogenic organism which is good for the composting process, that will be surviving by forming endospores. So this endospore will remain inactive during thermophilic phase, but again when the mesophilic phase started, it will become active. Active whenever the environmental conditions are favor, that is the mesophilic phase. So this is a good mechanism followed by the microorganism for its survival. Okay, this you please remember, non-pathogenic microorganism will form endospores, but pathogens won't form endospores, so they will die during this thermophilic phase. Okay, so that's the difference. and the number and the type of the mesophilic microorganism that are recolonized against in the compost. So whenever they become endospore during the thermophilic phase, they will again activate whenever the condition become favorable, and it will recolonize the compost, and it will help in the maturation of the compost. Okay, so average bacterial population during compost will be 10 power 6 to 10 power 12, that is the numbers, and fungal population will be 10 power 2 to 10 power 5, that is the population of bacterial and fungal population. Okay. Yeah. Then functional group of organism, we have four consumers that are the participants for the composting process from the microbe side. First one is organic residues, that is the solid waste we are providing. Then the primary consumers are organism that fed on organic residues like actinomycetes. Please check into the examples: actinomycetes, bacteria, fungi, snails, slugs, millipedes, some sowbugs, and some of the mites, nematodes and protozoa, which are all primary consumers that will directly act on the organic residue and it will eat. Then the secondary consumers are organism that eats the primary consumers. So like springtails, feather-winged beetles, and some of the mites, nematodes and protozoa that will eat the primary consumers. Then tertiary consumers are the organism that eat secondary consumers like centipedes, predatory mites, and rue beetles, and some pseudoscorpions also will eat the secondary consumers. So this is again a digestion process. It will completely degrade the organic residue or the organic part of the solid waste. Okay. Here you can see some organic waste that is eaten by invertebrates. I hope you all know about invertebrates that won't have backbone. So this invertebrates will eat the organic matter, and it will die, again eaten by microbes. Again microbes will be formed. Some microbes will live in the guts of the secondary consumers. It will again eat the organic matter present, organic matter that is consumed by the primary and the secondary consumers. So this is the whole process of composting. This is the temperature range, and different citations like at 10 degree Celsius, lower limit for the growth of mesophilic bacteria. So then 20 degree Celsius, it will actively grow some of the microorganism. Yeah. So at 20 degrees Celsius, some of the mesophilic microorganism will actively participate in the composting process. At 40 degrees Celsius, that is the upper limit. 40 degrees Celsius is the upper limit for the mesophilic bacteria. After that, thermophilic condition will exist. Optimal temperature for composting will be the thermophilic up to 80. After 80, no vegetation growth of microorganism. Okay. Yeah. And then after 65, only spores of the bacteria and actinomycetes remain. Other than endospores, no other microorganism will be actively participating in the composting process. Some of the examples are bacteria, fungi, and um, actinomycetes are actively participating in this composting process. This will be more biological, but some simple terms only like bacteria, fungi, and protozoa are the thing which are actively participating in the composting process. Simple process only. Yeah, it's a purely biological degradation process, not mechanical process. Yeah. So actinomycetes are you can see by its weight 100,000 to 100 million per gram of compost. After compost also, it will remain in the compost. These are the compost microorganism. Fungi 10,000 to 1 million, and bacteria 100 million to 1 billion per gram of compost it will exist. So there should be proper sanitation, sterilization before using the compost. In the maturation phase itself, all the microorganisms will die. Yeah. So another invertebrates we can also classify into microfauna, mesofauna, and macrofauna, less than 0.1 mm and 0.1 to 2 mm and 2 to 60 mm in size. These are all invertebrates actively participating in the classification of invertebrates participating in the composting process. And then phases of composting. These are the different components of organic matter. Any organic matter, if you take, that will contain sugar, protein, fat, cellulose, and hemicellulose. Finally, lignin. Lignin are the one which will take long time to degrade, and sugar is the one which will degrade first. So, before the end of thermophilic bacteria, all the sugar will get degraded, that is consumed, and then protein, fat will be degraded in the maturation phase. Cellulose, hemicellulose, some part of and more some part of cellulose and hemicellulose, and most of the lignin will be present in the matured compost that we will call as humic substances. That is very hard to degrade biologically. Okay, so there are again three phases of composting process. One is first lag phase and active phase. Final one is curing phase. That is the first mesophilic, thermophilic, and again mesophilic phase. So initially the microorganism will start growing. That is the lag phase, initial lag period. Then it will actively participate. That is the thermophilic phase, exponential growth of the microorganism. Then again the organism will start dying. So the number will be reducing. Final decline phase, which continues until ambient level are reached. Again 20 degree it will reach. That is called curing and maturation phase. So again we are going to elaborate the phases of composting. First one is the lag phase, which begins when the composting starts, and the microorganism will begins to develop, and pseudomonads are abundant during this phase. Pseudomonads that you just remember, during lag phase it will start uh, growing, and the phase will be very brief and putrescible. Uh, when putrescible matters are present in the solid waste, the phase will be very brief, that is very short. But if wood kind of items will be present in the solid waste, then it will take more time, that is longer. Okay, because wood kind of things are having more carbon, and the putrescible matter will have more nitrogen, so it will be very easy to degrade. And then second phase is active phase. In this active phase, the microorganism will start grow exponentially, actively participating, and uninterrupted rise in temperature. That's why it will become it will reach the thermophilic phase, and the peak it will go up to 70 degrees Celsius also. The peak will be at 70 degrees Celsius, and then flattening the temperature curve. That flattening is called a plateau phase. Again, it will start flattening. That is called a plateau phase. There itself, at 70 degree itself, it have some straight line. You can see again. I am going to that. So this flattened straight line is called a plateau phase. At the thermophilic phase itself, it will retain for some more time. That is called plateau phase. Then during this entire activation period, the substrate will get degraded with the environmental and proper environmental and operating conditions. Okay. Final phase is called a maturating or curing phase, where the decomposable matter is depleted, easily depleted, and final whatever the remaining matter like lignin and some part of hemicellulose will be present. That is called resistant material that steadily start rising, because all the organic matter which is easily decomposable will get degraded. So finally it will start increasing. The amount of lignin present in the compost will got increasing. Then the temperature begins to decline, and it will reach the ambient temperature. The time taken for maturation phase will be very high. Okay. If you see on the first day, the solid waste, shredded solid waste will be in a brown color. The proper compost after 8th day will be black in color. So this color difference itself, you can easily find the compost is matured or not. Matured compost will be in black color. The fresh waste will be brown or yellowish color. So you can see here the color change. Okay. Yeah. Then the factor affecting the composting process. Composting process is simple. What we call uh, decentralized process we can easily do in our household itself, backyard itself we can do composting, but we have to note down different factors that is affecting composting process. Then only we can easily achieve the achieve this process, and we can easily get the compost product. Otherwise it will be, there will be some nuisance of this bacteria, mosquitoes, and leachate, and some of the nuisance due to adder smell and all, you have to take care. So to avoid this, we have to maintain all these factors under optimal conditions. First factor is temperature. As we have discussed, temperature affects the microorganism growth, and it will the active participation of microorganism will be at the thermophilic phase only. So the microorganism temperature is the main thing. We have to maintain above 70 degrees, sorry, I mean within 70 degrees Celsius, and at higher temperature than 65 degrees Celsius, only non-spore forming will die, and spore formers can enter into the spore stage. As I mentioned, endosperms will be present until it reaches again to the mesophilic stage. So it depends on the ambient temperature, that is 30 to 35 degree in India we can maintain. So always we have to have a temperature sensor that should be digged inside the compost pit. Then we can easily monitor real time, monitor the temperature real time inside the compost pile. And this is the graph you can see. First day it will be at ambient temperature, it will start rising and it will reach 70, and again it will be reducing to ambient temperature. So this is kind of open composting. Here you can see hot climate region like India, we can easily do composting because it will favor the composting process. Because we need temperature for composting process. India is a hot climate region, so we can easily do composting. Take composting as a solid waste management option. So temperature affects the rate of composting, as I mentioned. So you can see different graphs also how the temperature is affecting the composting process. Whenever the cold composting is happening in colder regions and all, after 6 months only the compost will get reduces. But in hot composting with the oxygen, you can see 16 days itself 1 by 4 of this compost will be produced. That is fine compost. Here it will be a coarse compost. That is another difference between cold and hot composting. And as we mentioned, high temperature only this type of active bacteria will actively participate, and it will remove the pathogens. That is another one good thing. The pathogens in the solid waste will get removed because it cannot sustain at high temperature. But the non-pathogenic bacteria will form endospore and it will survive. The second factor we have to note down is the moisture content. How much moisture or the water content is present in the solid waste. If more moisture content is present, it will be anaerobic condition. If less moisture content is present, then the waste will be dry. Microorganism cannot degrade. It requires water for its growth. Like human being, it requires oxygen, it requires food, it requires water. So here we have to supply. Food is the solid waste we are giving, and then moisture is water is the moisture present in the solid waste. So these three things are important for the growth of any microorganisms, aerobic microorganism. Okay, so moisture also we have to maintain. So almost all biologically active activity ceases at a temperature moisture content less than 12%. If it is less than 12%, all the biological it will become dry. Dry waste, there is no microbial activity. That's what mentioned. So optimum condition, that is 50 to 60, that is very important. You have to note down. So 50 to 60 is the optimum moisture content range we have to maintain for the whole compost process. If moisture reduced, we have to add some moisture through sprayings like tubes and all we have to add. Then little moisture less than 40% inhibit the bacterial activity. Higher moisture content will produce odor because anaerobic digestion, and it will delay the composting process. So slow decomposition, and nutrients will be leached along with the leachates. So these are the disadvantages of having higher moisture content. Okay. So as I mentioned, microorganisms need oxygen, it requires moisture, it requires proper temperature to live and grow, and it requires the food, that is the organic matter, and the proper pH and the carbon nitrogen ratio. Yeah. So this is one of the field test we can do without any moisture sensor, or with moisture we can find with the oven, as we discussed in the characteristics of solid waste. Proximate analysis, ultimate analysis. In the proximate analysis, we have discussed about the moisture content, volatile, non-volatile, and ash. In the ultimate analysis, we have discussed about the elemental composition, CHONS, and calorific value, energy content, and all. Fusing point and all we have discussed. So without oven, how to measure the moisture content? So this is a field test or a thumb rule we can say. So we have to take the compost in hand and squeeze it. If water is coming out, then there is a excess amount of moisture is there. If the water is not coming out and it will become like a pancake kind of thing, then again moisture is also high. If it is coming back into its normal original position, then it is not too dry and not too wet. This is the optimum moisture content. We have to squeeze and take out the hand. It should spread all over the hand. That type of compost is good. That type of condition is good for the growth of microorganism. Or we can use this test for testing the final compost also. It should be free flowing without any moisture. It should not be so dry also. Okay. Then the third factor is particle size. Particle size, how it affects the composting process, because the microorganisms will always be present at the surface of the organic particles. See, microbial activity generally occurs on the surface of the organic particles. If the surface area is more, then the microbial activity will also be more, and easily it will be decomposed. So the time required for decomposition process will be reduced. So we have, instead of giving a big food particle, if you are provided with a smaller food particle, it is easy to digest. That's the simple principle. So we have to shred the waste less than 1 centimeter size, so that we can achieve the composting process easily. Without any delay. So decreasing particle size will affect the decreasing particle size will increase the surface area, as we mentioned. So it will also increase the rate of decomposition. If the particle is too small, again it will be very compacted and the air circulation will be inhibited. So we should maintain a proper size of less than 1 centimeter will be enough. If you are going too small, then it will be packed and there won't be any air flow. Again, the microbes will die. That decrease the oxygen availability. So the particle size should be in a optimum condition. So it will allow air, it will allow moisture to pass through, and it should have a proper pore space for the moisture and the air to flow. So that is the condition we have to maintain. So here you can see in the graph, if 1 centimeter, 1 inch diameter particles will attain the thermophilic phase than the 2 inch and 6 inch dia particles, because this will reduce the microbial activity and the production of heat. So again, it will delay the process of composting. So we have to shred and grind the solid waste to a size of less than 1 centimeter and to increase the surface area. Also, it is more susceptible to bacterial invasion, that is for movement and activity. And more uniform size makes the shredding will make the solid waste to a more uniform size and easier to handle, and it will keep the moisture, because more surface area, more water holding capacity. That is again everything related with the surface area only. Okay, then fly control is another important thing. It's also better when materials are pulverized and shredded. If it is a bulk particle, then flies will be attracted. And uniform compost made from the shredded material is easy for land application. Other than the bigger particle, it will be uniformly shredded, and then 1 centimeter particle will decay and form a compost of uniform size. It can be easily applied as a soil amendment. A degradation increases when particle size is low. That is the thumb rule. The fifth parameter, first one is temperature, second one is moisture, third one is particle size, and the fourth one is substrate. Substrate is the one, the waste we are giving or the food we are providing to the microorganism. That is called substrate. So here the substrate is the solid waste, the organic part of the solid waste. So it should have more organic matter, and it should have necessary nutrient in it. All the microorganisms will require carbon as well as nitrogen. Along with that, iron, manganese, potassium, everything is required for its proper growth. So we have to provide a mixture of nutrients for the microorganism to do the composting process. So combining the different kinds of compost material yield a mix that composts well, instead of having a single type of waste like wood or single type of waste like kitchen waste. Instead of that, a mixture of wood and kitchen waste will give you a good result. That's the proper mixing advantage. So kitchen garbage will tends to soft and fairly high nitrogen. Like that, wood waste will be more in carbon. So if you mix good carbon and nitrogen, then the bacteria will grow actively. That's the thing. Okay. So another thing is, whenever the compost is having less nitrogen, we can add some sewage sludge. Sewage sludge will have more nitrogen. And if you have lack of carbon in the substrate, then you can add wood or this type of sawdust, a dry particle. Or you can have a thumb rule, like dry particles are more in carbon and wet particles are more in nitrogen. That also you can say. Okay. So like wood chips, sawdust are carbon source, and sewage sludges are having nitrogen source. Then the fifth condition we have to maintain is the aeration. Aeration will add oxygen to the compost pile. So compost we are doing in a pile. That is the thing. A pile means a cone kind of structure where the solid waste is heaped. So there we have to allow the air to pass through so that the proper oxygen will be supplied for the microorganism growth. Otherwise, what will happen? The top layer will be having aerobic condition, and the waste that is present inside will be in anaerobic condition, and the anaerobic bacteria will start decomposing the waste inside, and it will produce methane and H2S gas, which will be an added nuisance, and it will create leachate, and it won't create much compost product. So methane will be emitted, that is a greenhouse gas. So we have to maintain a aerobic condition, so that the waste should be turned. The whatever the waste inside, after 3 days that should have come out, and whatever the waste that is outside, that should go in. Like that turning we should do. Or we have to keep a pipe, so that air should be allowed through the pipe with proper pores. Okay, so oxygen is a key element for the respiration and metabolic activity of the microbes, so it can be assessed with the oxygen demand. So temperature, moisture content, and the size of the bacterial population, everything depends on the oxygen demand. Okay, so if you turn every day, that is called turning and mixing. Without mixing, there will be anaerobic condition inside the heap. So we have to turn or mix the waste every 3 days, because after 3 days it will start become anaerobic. So every 3 days if you turn, then you can achieve the good thermophilic condition. Everything was related to temperature only. So every 3 days if you turn, then we can easily achieve the thermophilic condition. If you are not turning, every 10th day if you turn, again it will be reduced graph, and every 30 days if you are turning, you will be in the mesophilic condition only. Okay, so that's the thing. And if you see every turning, how much fumes are getting generated, that is the heat accumulated inside, it will be emitted. So every time if you are turning, you can see how much the pile, the compost pile is capable of reaching up to 77 degrees Celsius. That's what mentioned in the temperature factor also. That is the thermophilic condition it will reach. That's a peak. Yeah, so the pile will get hot and it will start decaying the matter. So the thermophilic condition is required. While turning only, it will properly generate this thermophilic condition, and it will decay the organic matter. By turning, oxygen is also allowed to enter into the compost pile. That is another mechanism. So aeration will help in aeration, or turning will help in aeration, also maintaining the temperature. So decrease in the chance of build-up of anaerobic microorganism. So we can also avoid the stinky compost and stinky smell during the around the composting area. So these are the things we have to avoid. So we have to avoid anaerobic condition. Composting means aerobic only. So there is no kind of anaerobic composting. Composting in the sense aerobic. So it will should have proper oxygen supply. Okay, then the sixth factor is called nutrients. So as I mentioned, carbon and nitrogen should be maintained in a proper ratio for the proper growth of the microorganism and proper participation, for the proper participation. So every microorganism will take 1 gram of nitrogen to decay 30 gram, sorry, in moles I have to say. For decomposing 1 mole of nitrogen, every microorganism will need 30 moles of carbon, so that it will be useful for its growth and metabolism. For that, the proper ratio, that is the ideal ratio of 30 should be maintained. So if it is 30 moles of carbon, then there should be 1 mole of nitrogen to be available for the decomposition process. So carbon is a source of energy, and nitrogen is a source of building its cell structure. So every microorganism will require energy as well as its body growth. So it requires carbon and nitrogen. So it requires energy and cell structure. So whenever the carbon to nitrogen ratio, you see first in the growth phase it will be reducing, and in the thermophilic phase again it will be reducing, and maturation phase carbon to nitrogen ratio will become 15, and it will be a straight line. So whenever the carbon to nitrogen ratio starts a stabilized phase, then we can say that is a maturation phase of composting. This is an indicator. So whenever the nitrogen, whenever the carbon is more, then means CBN ratio is more, means carbon will be more. Then it will take the nitrogen from the soil whenever the compost is applied to the soil field or agricultural field. So this condition is called robbing of soil, robbing of nitrogen in the soil. So robbing in the sense it will take the nitrogen from the soil. Then it will be like that there won't be any nitrogen available for the plant growth. So that is called the robbing of nitrogen. So we have to maintain a proper carbon to nitrogen ratio. If the carbon to nitrogen ratio is very low, then C will be very low. In the sense it does not help in improve the structure of the soil. So these are the two important things we have to note down while testing the carbon to nitrogen ratio of the final compost before application in the soil as a soil conditioner. Okay, so you can see here, if carbon to nitrogen ratio is 30:1, then only the temperature is achieved, that is the proper thermophilic phase is achieved, because more microbes are participating, actively involving. If it is 40 to 40 is to 1, then again it is in the mesophilic phase, and 60 to 1 is again in the mesophilic phase. So this ideal is 30 is to 1, C is to N is 30 is to 1. So carbon to nitrogen ratio is a critical factor in composting to prevent nitrogen robbing, and also to also to help maintaining the soil structure and microorganism cell structure. So you can see this is a thumb rule again. Two part of microbes. Oh, another one I missed. Sorry. Carbon will also be in the brown color. Nitrogen will also be in the green color. That is another thumb rule you can take. Like carbon will be in the, as I mentioned, sawdust and all. Nitrogen will be in green, like vegetables, grass, sewage sludge. Sewage sludge is also having nitrogen. That is again in the green color, we can say. So two part of brown and one part of green is a thumb rule. It will maintain, it will give you 30 to 1 ratio. Okay. So green you can see what are the nitrogen source, and brown what are the carbon source, you can check from here. Yeah. So how much C by N ratio will have, the rice hulls will have, the sewage sludge will have. So sewage sludge, if you see, C by N ratio will be very low, 5 to 16, because it's having more nitrogen, and moisture content will be very high. So to maintain the moisture content and the nitrogen content, you can add sewage sludge. It will improve the moisture, and as I mentioned, nitrogen having good moisture holding capacity. So mixing rice hulls with the sewage sludge. So that's the two things you can say. It's having high carbon, that is 1132 1120 C/N ratio. That is carbon is more. Sewage sludge is having 5 to 16. That is nitrogen is more. So mixing rice hulls and sewage sludge can give you a good quality matured compost. Again, mesophilic range, the C/N ratio will be higher, and in the maturation phase it will be lower. We have discussed already here in this graph also. Okay. So finally, we are going to discuss about the types of composting. Before that, we can brief the history of composting. So for last thousands of years, we are following this kind of decomposition process. That's composting process in old civilizations like Mesopotamia, Rome, and Greece civilization also. That we have some evidence of composting manures in the agricultural field. So they have also used this compost as a manure in the agricultural field. So if you see Sir Albert Howard, he is the father of modern composting process. He developed a method in 1930s and 40s. So it's a simple method. First, he taken a pile of waste. So he made it to compost. That is, it will start composting, because any organic matter will have some microbes. So it started decaying. But after 3 days, he felt some smell from the composting pile. So he thought there will be some anaerobic condition taking place inside the composting pile. So we have to take out that anaerobic condition matter to the top, and the top whatever is there should go in. Then again it will create some aerobic condition, because it's exposed to the atmosphere. So whatever the exposed condition, like these things and all will have good air condition. Whatever present inside is not having any air condition. So he turned after 3 days. So it have again the smell stops to come. But after 6th day it starts again. It start coming again. So he turned every 3 days. And finally, after 60th day, he got a good compost. That's the experiment he tried, and he proposed the modern composting methods. So in India, we have a traditional indoor composting method. That is, indoor composting method is layer wise composting method that we are going to discuss in the next week also. Different layers of composting, how can we do 14-day composting and kitchen composting, in everything we are going to discuss in the next week. And these are the different examples. You can see conventional pile composting, like what we are discussing. The pile is the conical form of the conical heap of storing the solid waste to become a compost. That's a conventional pile composting. If it is a pit composting, we have different tanks. So in NIT Trichy also, we have every institute you can see some solid waste management system will be there. So for managing food waste, they will use this kind of composting process only, or anaerobic digester for biogas production for the mess they will use. So every institute will have compost plant. You can go and visit in your institute also. So there will be 14 tanks or 7 tanks. So first this waste will be, in the next day it will taken and poured in the second tank, and in the third day it will be transferred to the third tank, and the second day waste will be coming in the first tank. Then the next day it will go there, like that. 14 tanks. After 14th day, it will become a matured compost and it will be taken out. And in NAT, we are using food waste mixed with whatever the fallen leaves for the nitrogen source and carbon source. We are mixing and adding as a compost substrate. Okay. Okay. So another one is like this is the direct trench compost or direct compost or trench compost. Instead of constructing a tank, we are having a trench in the ground and we can easily compost. This will avoid leachate problem because leachate will go into the ground and it will become anaerobic condition. So we have to properly turn the waste in order to avoid the anaerobic condition and the foul smell. Okay. So mechanization innovation will also happened in the composting process during the course of time. We have created different mechanism for the turning and aerating the compost pile. So we have to create some improvement in the aesthetic condition also. So you can see here this is a good drum that will turn the waste often and it looks good also. So aesthetically it's good. So solid waste management system will have some aesthetic improvements also. Yeah. So here you can see another example, that is a silo type digester. We should not say composting as a digester, but composting in a silo type digester using mechanical mixing it will have. Okay, it's again aerobic condition only. Okay. Then Viro blend technology, they produced and marketed kind of composter and they are sold to the farmers. And the marigold solar composter, here instead of rising the temperature thermophilic condition by the presence of microorganism, we are using the uh, solar energy to heat the compost pile. So that is another technology they have designed and this product is also available in the market. And these are the types of composting we are going to discuss. First one is the open process, second one is the reactor process. So every compost we have only two, composting will be having only two types. One is open process, one is reactor process. There is no aerobic and anaerobic composting process. Okay, so open in the sense it will be done in an open ground. Reactor in the sense it will be done in a closed reactor or a vessel. Okay, then we will call as a vessel composting also. So open compost process again have two different classification. One is agitated pile, that is windrow, and static pile or a aerated pile. Agitated pile is the one, is the pile will be turned every 3 days. So the pile will be turned, but in the static pile the pile will be stationary, but aeration will be happening through pipes. Whatever the pipes we have provided, we are supplying air and we are also supplying moisture if we need. So if the pile is turned, that is agitated pile. If the pile is not turned, then it is called a stationary pile or a aerated pile. Okay, so this we will call windrow. The agitated pile is called windrow, then it is called windrow composting. You can see a yellow color machine. I will zoom here. So this is a yellow color machine that is turning the compost. It will start from there to here. It will have a roller that will roll the compost and it will turn the compost. So this is called the agitated pile. So here there is no need of agitation, only the pipe for air supply. Okay. Then in the reactor pile, based on the direction, we are classifying again into vertical flow, horizontal flow, and non-flow. That is a batch reactor. This type of reactor compost also we are having. So basically we have three types. One is pile, that is agitated, and the pile which is aerated, and then in-vessel composting, that is a reactor composting. It may be vertical, horizontal, or a non-flow condition, that is a batch reactor also. Okay. So if we have low technology, then we can use agitated windrow. If we have mid technology, then aerated static pile. High technology is this type of windrow vessels. Which is suitable for which condition, we have to think. If it is a community kind of composting, we are collecting solid waste from whole village or a whole city, then we have to go only with this agitated pile or a static pile. We can't use this type of drum or a static in-vessel kind of composting we can't use for large quantity. So this also in the design consideration we have to check what is the quantity of the solid waste that we are going to treat. Okay, so we are going to discuss each type in brief. Like agitated and windrow composting is the one which receives large volume of diverse waste. Anything will be coming and we are adding moisture, we are managing the C/N ratio, we are aerating by proper turning. Here you can see when the machine is moving from this side to this side how much fumes are coming out. So to maintain the thermophilic condition we are turning every third day, and mixture of any kind of mixture we can use in this type of agitated windrow composting. And in static, I mean this type of universal composting, we have to use homogeneous material, but in agitated windrow composting we can use any type of substrate. In windrow composting, again static and agitated piles. Static pile we have a window system itself. Static pile we have pipes. Agitated pile we have machineries to turn. How to calculate the area required for windrow pad? Windrow pad is the one which is the platform that is used for composting process. So we have to calculate the total area required. So for each thing we can have the different shapes. If it may be rectangular, semicircle, trapezoidal, or a triangular pile. The pile shape, cross section of the pile I am talking about. So if you cut here, it will be a triangular or it may be trapezoidal. So based on this, we can easily calculate the cross sectional area and how much retention time, that is 14 days or 30 days or 60 days, based on the retention time and rate of feed, how much kg we are feeding per day divided by the density of the waste will give you how much volume of waste, volume of feedstock we are composting. Then after finding the area, we can calculate number of windrows. So how much feedstock per day by number of volume of one windrow will give you number of windrows. Then area of one windrow into number of windrows will give you total area required for the windrow. Then maneuvering area is the area required for movement of these vehicles or the turners. So that also requires some of the area in between the windrows. So that we can calculate with this manrow area required, area of space required. Then total of this windrow with the maneuver area will give you the total area of the pad. Okay. So you can see this is the mechanism of this turners. So the turners will have paddles inside. So whenever it moves through the pile, it will turn the waste. Okay. Then aeration in the window system, it will be turned windrow aeration or forced windrow aeration. Turned in the sense that's the agitated pile. Forced in the sense we are forcing through the pipes. Okay. So it will produce acid during a phase that is called the acid forming phase. So the temperature, green color is the temperature profile, mesophilic to thermophilic, again it will fall to mesophilic phase. pH, if you see the pH at the start, that is 6 or 5, it will reduce to 4 or 3 acid side, again it will go to 8, that is the matured phase. So whenever the pH of a compost is 7 or 8, you can say that is a matured compost. Whenever the pH of the solid waste is 2 or 3 or 4, then it is the acid forming phase, generation of organic acid. So it's under degradation. So if it is high pH, then we can say that is a matured compost. Okay. So at the high temperature phase only, we can say protein breakdown, that is ammonia formation will happen. So it will induce more smell. So these are all agitated aerated pile. They are turning the waste. This is forced air. That is static pile. We are having pipes. It will supply oxygen. So oxygen will be utilized for its growth, and foul gas will be collected separately. That is positive variation we will call. Then community level composting, as I mentioned, we can have a proper C/N ratio, because some people will bring kitchen waste, some people will bring agricultural waste. So a community based C/N ratio, composting will maintain a proper brown to green, that is a C/N ratio, that is essential to be maintained. And turning is also important to prevent anaerobic condition. That is another case. So proper moisture content, proper C/N ratio, proper nutrient, that is C/N carbon to nitrogen, then proper size of the waste, that is shredding is also required. So these are all the factors that will affect the composting process. Final one is the leachate. So as I mentioned, there is no turning here. This is a tank. They are putting all the solid waste. So there is no pathway for the oxygen to enter. So it will be an anaerobic condition. So whatever the moisture will fall out, and this anaerobic condition will also produce some of the H2O, that is a water vapor, can't escape, and it will become water collected down as a leachate. It is not the same leachate from the landfill, because landfill leachate will be very toxic. It will have high contaminants like heavy metals and all. But this is the leachate coming out of the organic waste. So it will have high nutrients, any calcium, magnesium, any kind of nutrients will be present in this kind of nutrient. So in this kind of leachate, so we can use this leachate for recirculation also. This we can add whenever moisture is required. This can be added again. So if leachate become problem, then you can add some dry leaves or grass clippings, yard trimmings we can use to absorb the moisture, and that will be a nitrogen source or a carbon source for your composting process. So how to manage this compost over winter time or a winter prone areas, like India is mostly a hot climate region, we can easily do composting, but how to do composting in a cold regions? So there we have to um, go for in-vessel composting, what we are going to discuss in the next week. That is a reactor composting, horizontal or a vertical flow or a batch reactor we are going to discuss. That's the suitable kind for managing compost in the cold regions instead of open composting. Okay. So hope you all understood about the composting process and the factor affecting the composting and different types of composting. Uh, we have only discussed about the open process, open types, and reactor we are going to discuss in the next week. So if you have any doubt, please post it in the chat box, or we will move on to the problem solving session. Or you can also unmute and you can ask any questions. Okay, so if you have no doubts, I will move on to the problem solving session. Uh, Please post the answers in the chat box. Yeah, I'll move on to the first question. So, which part of composting process involves active stabilization? Mesophilic phase, thermophilic phase, maturation phase, hydrophilic phase. Hope you got the question and hope you can see the screen. Which part of the composting process involves active stabilization? So we have two phases, two temperature phases, mesophilic, thermophilic, which will have a good active stabilization. Mesophilic, thermophilic, maturation, hydrophilic. Uh, no, ma'am, I guess. You please look into again. Active stabilization. First will be mesophilic, second will be thermophilic, final will be mesophilic. So where the active stabilization will be happening. So it will be thermophilic phase only. So you can see this graph. First will be mesophilic phase, last will be mesophilic phase, the center one is thermophilic phase. Here only active decomposition and stabilization is happening. That's what the question. Active stabilization is happening in the thermophilic phase only. Okay, hope you got cleared with this question. I will move on to the second question. In which phase of the composting process the humus is formed? Humus is the one which is the fully degraded organic matter. That is called humus substances. So which phase will have humus substance produced? Mesophilic phase, thermophilic phase, maturation phase, none of the above. Yeah. So maturation phase. That is okay. Here we can say both. In the mesophilic phase only maturation will happen. So both A and C are correct. I'm sorry with these options. So both A and C are correct. Mesophilic phase only at the end. So that's called the maturation stage. Yeah, A and C are correct.
Sir, sorry sir for interrupting. Why
Yeah,
not thermophilic phase?
for humus production.
Yes, sir.
No, no, no. Humus is the final product. That is whatever we are calling compost, which will humus is another organic matter only, but will contains mostly of lignin. What we call it will be difficult to aerobically or microorganism biologically degrade. So this type of part of hemicellulose and semicellulose plus this humic substances will be present in the compost at the matured phase only. So it won't be there in the thermophilic phase. So it will be formed at the end. Whatever the
Okay.
leftover we will call as humus substance. Yeah. In the landfill also, if you dig and if you whatever the thing you are getting, that is called humus substance. Or
Sir,
something we will.
your voice is breaking, sir.
Am I audible now? Hello.
Yes, sir.
Yeah. Whatever the if we are digging landfill and whatever the product we are getting is called a humus substance again. So humus substance is the one which is fully degraded organic matter. It will be formed only in the maturation phase. So it contains some part of hemicellulose, cellulose, and lignin. Okay. Hope you are clear. So here also you can see in the maturation phase it will be long, slow degradation of lignin and other highly resistance compounds. So which is resistance to the biological degradation, and the formation of resistant organic mixture, that is called humus. Here you can see the word humus. Okay, this is the highly resistant organic mixture. Resistance in the sense resistance to the biological degradation. Yeah. So that is called humus. So it will be formed only in the maturation phase. Hope you are clear. Can I move on to the next question? Okay. Yeah. Thank you. So another question. This one is like average bacterial and fungal population during composting process is dash respectively. How much bacteria population and fungal population in the final during composting process? Sorry, during composting process. Bacteria will be 10 power 6 to 12. Fungal will be 10 to 2, 10 power 2 to 10 power 5.
But I think D option.
Yeah, that's correct. Yeah. This is the thing we have discussed. So at heat, the average bacterial population during composting will be 10 power 6 to 12, and fungal population will be 10 power 2 to 10 power 5. So this is the condition we have discussed during heat inactivation also. So heat inactivation will reduce the microbial population, and all the pathogens will be pathogenic microorganism will die. That is one of the advantages of microorganism. Sorry, the composting process. And in the this type of non-pathogenic bacteria will form endospores. So this endospores will resist high temperature, high environmental conditions, and then after it will be the condition will become stable like mesophilic stage. The endospores will become active. So this is the kind of like it is sleeping during non-favorable condition and active during favorable condition. So it's a resistant mechanism or a survival mechanism, we can say. Okay, moving on to the fourth question. Which of the following phase of composting microbial profile declines? When the microbes starts reducing. Mesophilic phase, thermophilic phase, curing phase, none of the above.
Curing phase.
Yeah, that's correct. So option C is correct. That's the curing phase. So here you can see we have lag phase, active phase, final one is curing phase or maturation phase. In the lag phase, mesophilic condition will be there. The bacteria, microorganism will start growing and it will start to adapt. And then in the active phase, thermophilic condition will prevail. Exponential growth of microorganism will happen and actively participate in the degradation process. And finally, it will be again mesophilic phase, and the bacterial population will start decreasing and the compost will become mature. That is the maturation. So the question is like whenever the population starts decreasing, one of the final decline process is called a curing phase. Okay. So fifth question, in composting process microbial activity occurs on the surface of dash. We have discussed this in during the particle size concept. That's a factor affecting the composting process, particle size. So in composting process, microbial activity occurs on the surface of what? Particle is correct. Yeah. Which particle? Water particle, air particle. Sorry, air is not a particle. Sorry. Technical term is substrate or solid waste. That is correct. Yeah, solid waste. That is the organic particles. Organic matter of the soil waste. That's the concept. That is the substrate we will say. Yeah. Here you can see
In that blank, can we write compost molds?
what's the answer you have mentioned? Compost?
Molds, sir. MOLDS.
Compost molds. No, compost is the final product. So first, whatever the thing we are having is a solid waste only. So the microbial activity will be happening on the organic fractions of the solid waste. So it's over the organic particles only. That's correct. It won't be
Okay.
on the compost. Yeah. So here you can see the microbial activity generally occurs on the surface of the organic particle. That's why we are increasing the surface area by shredding. So if you are maintaining a particle size of less than 1 centimeter, then we can get more surface area that will allow it will have a good pore space for airflow and water flow and for proper microbial activity at its surface. That's the concept. Yeah. So the sixth question, which composting process is performed in hot and cold climates? For hot, which we are preferring, and cold, which we are preferring. The two types you can say. We have two types of composting. One is so okay, I will tell both the types. One is open composting, another one is reactor type. So which is preferred in hot climates and which is preferred in cold climates, respectively, you can say. Open for hot climate, yeah, correct. And then reactor type or universal composting for cold climate. That's the answer. Open and universal composting for hot and cold climates. Okay. Yeah. So because why? Because like open composting, we need lots of space and it will be open to the environment. So the cold climate won't adapt to this situation. And reactor kind of thing will be useful for cold climates. Yeah. Then moving on to the next question, what are the product released after curing phase of composting? So this also we have already discussed. After curing phase, what is the product that is released? No, not CO2. Pathogens, CO2, humic substances,
Humic
oxygen.
substances, sir.
Yeah, humic substances are correct. Because after curing phase, there is no microbial activation. So during microbial activity only, the organic matter will be degraded and CO2, H2O, water vapors will be formed. But curing phase, there is no degradation. So only humic substances will be formed or released. So we have to after curing phase, only humic substances will remain, and that is the product released. That's correct. Pathogens won't be there. Why? Because in the thermophilic stage itself, pathogens will die. Non-pathogenic microorganism only will be present along with the humic substances during curing phase. Okay. Yes. So which of the following are the secondary consumers present in the compost? We have three consumers are the participants for the organic matter decomposition. One is the primary, secondary, and the tertiary consumers. Yeah. So the first one is they're asking about the secondary consumer example: springtails, snowbugs, centipedes, predatory mites. So this is difficult to remember, but just look into the example. The answer is actually springtail. That is correct. Yeah. So here you can see organic residue will be acted upon with different consumers. That is a primary consumer. Primary consumers will be eaten by secondary consumers. Then the tertiary consumer will eat the secondary consumers. Like that, it will move on. So the examples for secondary consumers are springtails, feather-winged beetles, and some types of mites, nematodes, and protozoa. This is present in both all the things. Okay. So ninth question: in which phase of composting pseudomonads are found? Pseudomonads. We have three phases: lag phase, active phase, and the curing phase. In which phase of composting pseudomonads are found?
Active phase, sir.
No. Uh,
Active phase, sir.
uh, I don't think so. Lag phase, yeah, that's correct. C is correct. Because we have discussed in the lag phase, pseudomonads are in abundant in this phase. And the protozoa and fungi are not discernible. So pseudomonads are found abundant during lag phase only. It will start growing abundantly during lag phase only. In active phase, the microbial population will be higher, but pseudomonads will be higher during lag phase only. Okay, so please remember this one. Okay. So the tenth question, what is the optimum moisture content required for composting? 20 to 30, 30 to 40, 40 to 50, 50 to 60. What will happen if there is less than the optimum moisture content? The waste will be dry. There is no microorganism. It will be inactive.
30 to 40%.
No. So if it is more than optimum,
D.
not B, D. 50 to 60 is correct.
Yes.
50 to 60 is correct. Then if it is less than the optimum, it will be dry. There is no activity of microorganism. If it is more, then it will be like a, if there is no pores are filled with water means it will be anaerobic condition. So anaerobic condition, foul smell will come, anaerobic bacteria will prevail, CH4 will emit. So again it's not a composting process because it's not aerobic. So we should maintain optimum moisture content, that is 50 to 60. That is the optimum moisture content mentioned here. 50 to 60 is the generally considered optimum for composting. If it is less than 12, bacterial activity ceases. If it is more than 65, slow decomposition, adder production due to anaerobic decomposition. Yeah. What is the desirable organic particle size for composting?
B. Less than 1 centimeter.
So more than 1, less than 1, 1 to 2, 2 to 3 centimeters. So note on the units also, less than 1 centimeter is correct. Yeah. Okay. So recommended size of particle is less than 1 centimeter to increase the surface area of the substrate. Then what is the ideal C/N ratio for composting? 30, less than 15, less than 30, greater than 30.
30.
Ideal C/N ratio. 30 is correct. So which is 30? C or N? C/N ratio. C/N is 30.
C,
C
sir.
is 30. Yeah. C is to N, 30 is to 1. So for 1 part of nitrogen, it requires 30 parts of carbon. Any microorganism requires, because carbon is the energy source, nitrogen is the metabolic source for its cell structure to grow. For its growth, it requires nitrogen. For its energy, it requires carbon. Humans also requires carbon and nitrogen because nitrogen is a part of DNA metabolism, so it requires nitrogen. But if more nitrogen is there, then it requires more carbon to degrade. That's the problem with the final compost. If it is having more carbon, then it will absorb nitrogen from the applied soil, from the agricultural field. If it is the C/N ratio is very low, then it requires carbon. So the soil structure won't be improved. That's the problem. So the ideal ratio is 30 parts is to 1. Which of the following is an open process of composting? Vertical flow, inclined, batch static pile. Open process. We have two processes. One is open and the reactor one.
I think D, sir, static pile.
Yes. So option D is static pile. Another one open process is these three are reactor type. Two are open process. One is static pile. Another one is
Inclined.
no. How it will be open? Other three are reactor type only.
Agitated wind.
Yeah, agitated windrow pile. Yeah, that's correct, ma'am. So in open process, we have agitated windrow pile and static pile, that is aerated. Because whenever the pile is static, we have to give pipes. Whenever the pile is not static, it should be agitated. So that are the two open process type. Other three are reactor types only. Vertical, horizontal, non-flow based on the flow condition. Super. So at what temperature the non-spore formers die during composting? Non-spore formers are pathogens, we can say, will die.
Above 65.
Above 65, below 65, above 20, below 20, above 65.
Yes, sir, above 65.
Yeah, that's correct. Above 65 is correct. Yes. So you can see in this temperature chart, 60 is the upper limit for the growth of thermophilic fungi, minimum target temperature for killing pathogens. After that, only spore bacteria will survive. That is the spores of the bacteria and actinomycetes remain viable. Others will be died. So that's the problem. After 60, there won't be any microorganism, non-spores will be present. Okay. So this is a multiple choice question. Please look into it. Why turning is important in composting process? To avoid anaerobic condition, to decrease the pH, to avoid the aerobic condition, to prevent foul smell. You can take it as A, B, C, D. What are the options are correct? More than one option may be correct.
A, B, And
A,
D also.
okay, A is reasonable. Okay, to avoid anaerobic condition, we are turning. So it's again related with the D to prevent smell because the anaerobic condition will create smell. So A and D are correct. How B to prevent pH to decrease sorry to decrease pH. Why we need to decrease pH in composting process?
Initially, the pH is acidic,
But we don't
so
want that, right? Answer is A and D. The pH turning is not related with the pH change. Maybe we need acid formation during this thermophilic that's microbial activation phase, but that is not the purpose of turning. Turning is only to avoid anaerobic condition, to prevent foul smell, and to aerate the pile. It's not
okay.
nothing to do with the pH for turning. Yes. So
There
here,
in this pH is important or not, sir, in this condition?
pH is not required to maintain for the compost. But when it is going to apply in a agricultural field, then the pH of the compost should be important. And pH is also required for the microbial growth. So some part of the pH, this different types of microorganism will grow in acidic phase. Some part of microorganism will grow in alkaline phase. So most of them are aerobic only. So we won't have pH as a factor for composting. Okay, so for
Sir.
final compost should be checked with the pH. So we have a regulation FCO standard, food and compost order, we can say. You can download from internet. FCO standard 1998 is there. In that, what are the tests we have to do for the compost to be used as a soil conditioner or a fertilizer? For that, I can also show that I have the document. Yeah, I will show the document once. Government. So this is the sorry, this is the requirement. Sorry, biofertilizer and organic fertilizer. This is the fertilizer control order (FCO). Here you have how to estimate pH, moisture, conductivity, organic carbon, nitrogen, CB. These are the procedure they had given. Potassium and heavy metals because compost is coming from solid waste. So it may have some heavy metals also like mercury, arsenic also. How, and finally pathogenic test. What are the microbes that is present in the final compost also we have to test. So these are the different tests we have to do and what are the limits also they had given. So this is the procedure how we are going to do all the tests. In that pH is one of the tests as I mentioned. So finally the limits I will show you. Yeah, these are the limits. Specification of organic compost. So moisture should be this much, color, particle size, density, pH should be 6.5 to 7.5. So this is the range for the final compost. CBN ratio should be less than 20. So for proper composting, it should be 30, ideal composting process. But final compost will have less than 20 only because it will start reducing as we had seen in the graph also. CBN reduces and attains 15. Okay, so final compost will should have moisture, NPK. NPK is also required, nitrogen, potash, phosphorus, because whatever the soil for agriculture, we will test for NPK also. So these are the condition. I'll share this document in the problem solving session folder. You can look into it. Okay. So that's why pH is also important for the final compost, not during the composting process. Yes. Hope you are clear. I will move on to the next question. Which part of composting process involves active stabilization? This we have already discussed. Thermophilic, lag phase, log phase, and mesophilic phase. This is therm. Yeah, the answer is thermophilic phase. And which phase of the composting process is humus produced? That is also we have already discussed the mesophilic phase. Fine, first one is also mesophilic, final one also mesophilic. Yeah, this is also already discussed. Which of the following phases of composting? Microbial profile decrease, that is log, active, and curing phase.
Curing.
Yeah. So final one is like objective for shredding of raw material for composting process. What is the objective of shredding? It will decrease the degradation process. It will increase the bacterial invasion. It will decrease the moisture. It will reduce the odor
Increase bacterial invasion.
invasion. Why? Because we are having good surface area, so good microbial activity. So that's the thing. Shredding exposes greater surface area, making more susceptible to bacterial invasion. Okay, so that's it for today. Thank you so much. If you have any doubt, please unmute and ask, or you can also post it in the chat box. If you don't have any doubt, you can leave the meet. That's for today's session. Thank you so much for joining. Thank you all.
So session is
Thank you.
completed.
Yeah, for today it's over.
Oh, okay, so okay.
Thank you.
Thank you so much.
Thank you, so.
So if you don't have any doubt, you can leave the meet. Thank you. I'll be in the meet for next 5 minutes.
Mr. Saravanan, I have a question.
Yeah, ma'am, please.
So, is there any success model of any panchayat or urban local body who is following this composting process?
Yeah, every municipality we are having lots of composting plants, ma'am. In Trichy itself, we have more than 50 micro compost plant. You can see MCC, a micro compost plant, that is successfully running in all the panchayats, ma'am, and municipalities.
Okay, okay. So, Tiruchi,
But
is there
Trichy, it's there.
anything in Virudunagar district that you can suggest?
Yeah, I'm actually from Rajapalayam. Are you from
Okay.
Virudhunagar district?
Yes, sir. Yes, sir.
Oh, I am from Rajapalayam. In Rajapalayam itself, we have 4 compost plant.
Okay, okay, okay. Fine, fine, fine.
So, but the process may be varying. It may be universal or it may be what we can say open reactor. But mostly they will, if it is a community level, they will go with windrow composting. And most of the places I have seen this type of pit composting, like 14 tanks or 7 tanks like that. Yes, ma'am. So you can
Thank
also
you.
visit any of the MCC in your premises. Where you are from, ma'am?
I'm from Virudunagar.
Okay, okay, ma'am. Nice to meet you. Thank you so much. You can also
Definitely.
visit a micro compost plant in your area, ma'am. You can also
No,
have
I've
the access.
visited. I have
Oh, okay.
visited, but the level of precision, I don't think they do, but they do
Yeah,
it to a level of.
that's actually what they will say. Like based on experience, they will add the waste. The quantity and the quality is not based on test, only based on the experience. And the final compost they will send for laboratory test. It is not like every time they will measure the moisture. Every time they will measure the CBN ratio. It's not like that. So there is a proper guideline for them. So if it is a mixture of, before starting the compost plant, they will have a proper analysis of the characteristics of the solid waste coming to the compost plant. So with that ideal characteristics, they will start. So every time it won't be, it's not required to monitor. So it will be an ideal condition they will follow, ma'am.
Okay, okay, okay,
Yeah.
okay.
Thank
So
you.
what is the objective in the Prime Minister's research fellow scheme?
It's not, it's actually a fellowship to promote research for engineering and science background, ma'am, actually. So we have
Okay.
to, as a IIT student and NH students are eligible for this PMRF. I can also show you the, one second. The PMRF website you can go through, that is the Prime Minister Research Fellow. What are the institutes are eligible? So all the IITs and the NITs which is having rank less than 25, NIRF rank less than 25 are eligible for PMRF. As a PhD scholar, we have to submit a proposal to the government of India about our research. So after interview, we are getting selected and we'll get some fellowship, ma'am, for doing our research. Yeah, we have yearly reviews also. These are the various institutes eligible for PMRF. So NIT Trichy is one of that.
Great, 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 great,
Yeah.
great, great.
So so we have PhD scholars are having TA works in the institute also. Other than that, we are getting extra fellowship from the government of India. So we have to teach in nearby government colleges or government polytechnics or schools, or we can also teach in NPTEL. We can also take TA ship from the NPTEL. So as a part of PMRF TA ship, I am taking this course, ma'am.
Okay, fine, sir,
Okay.
fine.
Thank you. Thank you so
Thank
much.
you so much. Thank you.
Yeah. Thank you so much. I'm closing the meet. Hope you don't have any doubt. Yeah. Thank you so much for joining.